During this session I'm going to be talking about vertical motion, the art of falling as shown so effectively by Wile E. Coyote, but unfortunately he doesn't always obey the rules of physics. The rules of physics means that this world is much easier to understand because there's a few basic points. Basic point number one, acceleration is constant. If we think about it, even if we throw our object upwards, the acceleration is 9.81 meters per second downwards. So the ball will slow down whilst going up and then speed up whilst going back down again. So we normally set the acceleration to be minus g, depending where our reference point is. Okay, so if we're just dropping a ball downwards, we might say the acceleration is g. But nevertheless, the value is of the magnitude is always going to be constant. Another one of the rules is what goes up must come down, and the important thing we can recognize is that if things go up, they eventually reach a point when they're momentarily stationary, so that means their velocity is 0, and when they come back down again, the velocity at the point where they were launched from will be equal in size but opposite direction of the initial velocity. So in this case we can see that the ball was launched up with plus 20 meters per second, and in this case 4 seconds later it returned to the ground at minus 20 meters per second. So that's one point. So what goes up must come down. Let's think about how we can apply this. We'll think about a vertical projection. Okay, so this is throwing something upwards. You hit a cricket ball vertically upwards at 40 meters per second. How high does it go? Think about this problem, try and solve it. Now, as ever, I try and advocate using the guess process. So first of all we look at what's given in the question. The given values are 40 meters per second is the initial velocity. We know that it's going to deaccelerate at 9.81 meters per second squared, and we know at the highest point the velocity is going to be 0. So there's some given values there for us. Our unknown value is x, so that's the displacement. If we look at v squared equals u squared plus 2ax, that's the equation we're going to use. We can rearrange that to give us x equals v squared minus u squared divided by 2a, and that gives me a final value of 82 meters if I plug in the numbers that I've got. Now notice here that v squared is 0, so minus u squared is going to be a negative. V squared minus u squared is going to be a negative number, and minus 2a, the acceleration is going to be a negative number as well there. So therefore it comes out as a positive overall. So that's one example. Now I'm going to introduce a set of thinking which is often comes across is used experimentally. So there's a bit of thinking that if we fall under gravity, let's consider that situation. So, if we describe a ball dropping from a height with respect to the equation x equals ut plus half at squared. Okay, so we're just using another equation of motion. Thinking about this, we know that the initial velocity is going to be 0, and again we're going to find that the acceleration is equal to g. Now this means that my formula suddenly simplifies. X equals half multiplied by g times t squared. Now this becomes really useful because we can rearrange for g, and that means 2 times x divided by t squared, and this means if we're making some measurements with a ball dropping from a certain height, the height x, and measuring the time, and if we do this over a series of different heights, we can actually get a graphical result. So if we plot 2x against time squared, the time it takes to reach the ground squared, then what we find is the gradient of this graph is going to give us a value for gravity, assuming that there's no air resistance. So it's a common practical which people may use. So that's all the ins and outs of falling under gravity. I hope this helped.